And I'm going to refresh this.
Okay, hello, Houston. We have ignition. Or as they say on Star Trek, warp speed, engage. Once a week online live vlog and pen. What do we call that? Podcast. Podcast, I guess, for you sight impaired. You can hear us talk for the Santa Barbara, California Longtime Telescope and Astronomy Club, the SB Astronomical Unit. Heard and seen Mondays, 11 a.m. to noon for an hour. We call it the SBAU Astro Hour. I'm your proud host and re-elected Vice President Friday night, Ron Herron. Also re-elected the President, who we'll introduce you to along with members of the board here in a moment. Got new posts filled for Treasurer and Secretary at the club. Meantime, follow us on YouTube, just connected, and be ready to comment and ask questions. Somebody's monitoring that at the bottom of the screen. I got to tell you, though, these are some of the brightest, most knowledgeable people I've ever known. Come and join us on First Friday. You missed it this month of December. Missed a grand time in Farron Hall up at the Museum of Natural History, which supports us. But you can get there this coming Saturday night for our second Saturday Star Party at the Museum of Natural History. It's a little free half-hour show in the planetarium that's just awesome, especially since it's been refurbished. So let's find out what we're going to talk about. Then I'm going to introduce you to the guys. It's time to see the winter triangle, something like the summer triangle, maybe not as best known, but the innermost planet. Mercury is our new evening star, early evening, I assume. We'll talk about that. Coming up the last quarter of our waning moon, and we'll visit Rupi's recta. Sounds like a visit to the proctologist. It's also close to a double star system, at least the moon is, that we'll visit. You can see them distinctly apart. We're going to talk about it. There's a new comet in the sky, Shuchinshan 1. And astronomers are zeroing in on, get this, the first planet-forming disk ever spotted in another galaxy nearby. It's the Large Magellanic Cloud, like going back 4 billion years in our solar system. Okay, it's time to meet Jerry Wilson, president again, Jer.
Good morning.
Nice to see your face up on the screen. I wish we could have heard you Friday night. We finally got the sound system straightened out and it wasn't distorting, because at the beginning, I guess I was too close to the microphone.
No, it wasn't you. It was something. It sounded like a reflection from two things being plugged together that had a different impedance. And you can get a reflective interface electronically.
Well, I think that's because there were two laptops being used with the Zoom. I think one was Tom's and one was John's. And I bet you that's what's happening is their microphones are both picking it up.
It might have been. Also, all of a sudden, it just got real clear.
Good.
And then we got new members on screen later in the evening. Otherwise, it was a good night. I was happy. We were both reelected. Jerry's married to Pat Forgy. And this will be, what, year number 7 for you?
Something like that.
I think year number 6 for me. Chuck McPartland just speaking to us, our outlandishly outreachable outreach coordinator, married to Pat, who is in charge of merchandise for the club, as well as our new treasurer, taking over for stepping down Colin Taylor. We also have, and he was in attendance and didn't know it, Tom Whittemore, editor of our monthly newsletter. Tom.
Morning.
Former science instructor out at Westmont College, beloved as he was. And he let a stupid little thing like a pandemic kick him out, I guess. He's married to Maureen. And Lord Loveduck, it's Tim Crawford, a regular resident on the screen with us these days, and telescope expert as far as I'm concerned. Plus, you ask a lot of good questions, and you've been married to Karen how long? How many years?
I think about 37, something like that.
You guys starting to get serious about each other, huh?
Time flies.
All right. We always start our show, and this happens to be number 146.
But he's in the doghouse.
I'm telling you a couple of things. By March, we will be going into our 4th year of doing the Astro Club thing, the Astro Unit. What do we call this show? SBA Astro Hour.
Yeah.
Time to look at the sillies. Aliens in a spacecraft with definite Christmas spirit. What? I thought it would help us blend in. That's all right. Sure. Right there above 405. And this, you got to enlarge it a little bit. Bob Zimmerman is the name of Bob Dylan when he was young. And He's sitting in the classroom, and the teacher says, "So, what method do dandelions use for seed dispersal? Bob Zimmerman?" "The answer, my friend." Anybody can do Bob Dylan?
No.
I knew somebody that could in radio, but that's where it came from. Blowing those little seeds off the top of the.
Yeah, blowing in the wind.
Right.
You sent us 12. I don't know if you're going to get all of these. This one I don't remember. I do remember. This is a cat, and this is on the right is a close-up meeting. What the?
I see the cat has got a cat pattern of fur on the back.
Oh, I see. I didn't really.
Yeah.
Did any of the rest of you see that?
Yeah.
Square root of a cat. Okay. And here's Calvin without Hobbes. He's with Dad, and he says, "Dad, how do soldiers killing each other solve the world's problems?" And Dad just totally stumped, can't come up with an answer. And Calvin walks away. I think grown-ups just act like they know what they're doing. Dad couldn't answer that one. Here's
This might be a repeat for me.
No, I haven't seen this one, but this is the dreaded aliens dropping the broken bottle from space containing the deadly human. Homo sapiens virus, which hit the Earth about 1 million years ago, maybe. Yeah, it was that a little bit too for the Dilbert fans, because he's talking to the boss, and MFU. It sounds like a dirty word, and our 4-letter dirty word with an F is foul. So it's the management foul up. I guess that's the boss sitting there, right? With the strange hair.
Yeah, the pointy-haired boss.
"What does MFU2 mean on your timeline, huh?" Gilbert says, "That's management foul up number 2, boss. It usually happens around the 3rd week." And he says, "We don't anticipate any management mistakes." Gilbert says, "Oh my God, that's MFU2.
That's MFU1.
Oh, that's it. Oh, it looks like a 2. Okay, that's the first one. I got it. MFU. A little like, here we go.
This is good.
Rene Descartes thinks, he thinks, therefore he is. Which is a way of putting it, but it's not how he said it. Descartes, when he realized people who don't think also exist.
Yeah.
We know who those are. And it's got to be Lucy and Charlie Brown talking out in the rain. Peanuts.
That's Linus.
Oh, that what? Oh, was that Linus?
Yeah, and these are starry nights, not rain.
You're right. It's a starry night. The biggest star measured, she says, so far has a diameter 2,000 times wider than that of the sun. Gee, Linus, I wonder how they measured it. And they're thinking about it
With string.
with string, I think. And we love those. Enlarge this a little bit so I can read it. Okay, this is the nerd from hell talking to God. Nerds for Jesus, I guess. Got a steaming earth there on his table. Looks like your whole dinosaur system is wiped clean, boss. You really should have invested in some anti-meteor protection, you know. How do you feel about upgrading to Mammal OS X? You want to explain that? What is OS X?
Oh, it's just
Macintosh.
operating system.
Oh,
Yeah, new operating system.
Okay, these are typical daytime teenagers today. They're always walking around instead of walking into a pole. He looks up for a change. Hey, when did we die?
They don't notice.
Okay. Now I get it.
Now he got it. Okay, well, you sent out 12, and we got about 8 or 9, 10 of them on the screen that time. And the ones you didn't do, you can do next week if you want. And incidentally, gentlemen, before I do a quick recap with Chuck about outreach, the 2 of you at the bottom of my screen didn't hear us talk about Christmas Day is Monday, 25th. And we've decided we're going to be here. What? And even Jerry's going to be out of town. I got no other life going. I don't have a lot of family, but Chuck, you're going to be with us in 2 weeks, 3 weeks?
Sure, yeah.
How about you, Tom?
I can.
I'm not sure, but I'll try to get here. Okay.
All right. Well, Bruce Murdoch is not with us today, but he did bail out. Saturday night, 6 o'clock. People start showing, or 7?
7 o'clock.
7 o'clock.
It's for the star parties. Second Saturday of the month.
Okay. And then we'll have a little meeting in the afternoon earlier than that, and recap the election and other things. Let's go to the screen and talk about space on this what is it? The 4th of December?
Yeah, December 4.
Yep.
So this I've switched on this for this week. I've switched from the planetarium software, the Sky 6 to the Sky X here. So the presentation is a little different.
Okay.
I'm not completely in control of this yet, but this is centered on, even though it says Plaskett star, that's up here. This is the Rosette Nebula here.
Aha.
And this is the rich region around Orion. And it shows 2 of the Winter Triangle stars, Procyon, Betelgeuse, and then down here, the brightest star in the sky, Sirius. And this is an actual photograph of the Winter Triangle. Betelgeuse, Procyon over here, and Sirius down here, spanning the other one, just cut off about here from the planetarium chart.
You can see the rosette there.
Yeah, you can right there. This faint red haze around there. Now, the winter constellations, the winter sky has brighter stars than the summer does. And a lot of them are right here. Certainly has the brightest star.
So this is the Winter Triangle.
Yes.
Okay. Can we not see it in the summer?
No, you have to be able to look at the sky with the sun in it.
Okay. Do they have their own triangles in the southern hemisphere, you suppose? Australia has theirs, don't they?
Any 3 stars, just about.
Yeah.
They also
People
have a
make
southern...
up all sorts of asterisms.
That's true.
Well,
There's
I think that the rosette in one of my scopes anyway, it flips the image. So the rosette would be, if you draw a line between Betelgeuse and Procyon, it's a little bit above it. It's about 4/5 of the way across. It's not quite half, but then, I don't really know a good star hop for that, Jerry. It's just kind of, I just use Betelgeuse and Procyon.
Right.
Well, that might be it right there. If you see that little bit of purplish haze.
Yeah,
that's
this,
right.
this is
right.
it. Yeah.
Yeah,
Well,
it's about 4/5 of the way.
So Tim, you can
Yeah.
see the belt stars point to Sirius. That's something Chuck taught me. So that must be Sirius down near the bottom.
Yeah, it is.
Yeah.
Mhm.
And this is Procyon over here.
Yes. Yes.
What's the little green thing up there?
That is an artifact from the picture, and I don't know what it is.
Christmas tree.
Yeah.
Otherwise, the stars have their natural colors. The upper right is yellow.
Yeah.
Yes, this is does show the colors of things.
And you can see the Orion Nebula down there.
Right.
Yes.
Right here in the sword star. So the sword, 3 stars or 4 stars, and the middle one is not a star, it's the nebula. So
Yeah.
when you see a star there, you're actually, with the naked eye, you're actually looking at the nebula.
Yeah.
Yep.
Hey, Jerry, do you mind if I make a comment about Plaskett's star? It's a
Go
dear to
ahead.
my heart. It was on the previous thing. You had it on your,
Right there.
yeah, I used to have that on my test at Westmont. So Plaskett proposed there could be a star so massive, okay, that light could not get out of it. And so I used to give that to students for their test. He was the guy, Plaskett's star.
Light couldn't get out of it.
Well,
Light
the
could
black
not
hole,
escape it.
essentially.
He kind of, although he never used the word black hole, John Wheeler did, he kind of proposed a star that could be so massive that light could not get out of it, which is kind of like a black hole, huh?
It is a black hole.
Yeah. Well, that goes way back to like Laplace or somebody too.
That's right. Yeah.
Yeah, someone speculated on it a long time ago, I know.
Plaskett star.
At Plaskett. Mhm.
And this is a really like a massive binary system, I think. Plaskett star.
Okay.
Does anyone know anything about Luton's star over here?
No.
Leighton?
I think
Lloydton.
that's one of those close red dwarfs.
Yeah. It's a Dutch name, Leighton.
Yeah, it looks Dutch.
I think old man Luton passed away, though.
Probably.
You were talking about rosettes, and then I believe that was what you added in your follow-up updated to the talking points, Jerry? Is that what you added? Rosette's nebula called what?
Yes, I was going to add a lot more, but they're pictures only, so I didn't put them in what I mailed out, but we'll see them.
Just
This
did a
is-
quick lookup of Leyton star, and yeah, it's a red dwarf, 12.35 light years away. So
Okay.
A red
That
dwarf?
might be an interesting dedicated topic for another show.
Okay, that's pretty close. 12 light years. That's why we can see it if it's a
Three
red dwarf.
times Alpha Prox Centauri.
Yeah.
So
Is
this is the Rosette Nebula.
Ah,
You can see all sorts of dark concentrations in here and little dark spots called Bach globules, which are gravitationally pulling together the dust and form the start of accretion disks and stuff. Now, there's a lot of stuff in here. There's the Rosette Nebula. There's a star cluster in here. And as a matter of fact, there are, I think, 5 NGCs in this picture.
Wow.
NGC 2237, part of a nebulous region, also used to denote the whole nebula. Another part of, and that the reason these have different names or different numbers is because this was a very bright thing, and people with big telescopes back in the 1800s could see parts of these and didn't see all the connecting nebula between the brighter areas. So they individually named these different bright areas. Now we can take a picture and get in small scopes, and we can get the whole thing.
oh. Well, you listed 5 NGCs, 223, 227, 2239, 2244, and 2246
Yes.
are all there.
2239 was discovered by John Herschel. 2244 was discovered by John Flamsteed in 1690. So it goes way before 1800s.
That's the center cluster, I think. The
Yeah.
2244.
Yeah, that's the star cluster.
Yeah.
So we're not looking through a donut hole at the big stars in the middle that are in the background. They're part of this, right? They're in the middle.
they've sort of blown a hole out of it. They
Yeah.
formed in it and blew a hole out of it.
Oh, I see. Well,
This
what
is-
is
A little
This is-
comment, Jerry, is that when I was in the club up in San Jose, one of our members left and moved to Portal, Arizona. And he said he could see, that's out in the desert country near the Chiricahua Mountains. And he said he could see the Rosette naked eye easily.
Wow.
Good grief.
It's big.
Yeah.
There's like a
It's-
mini Trifid nebula up there at the top at like the 1230 position.
Yeah.
Well, here's what you say in your notes, Jerry. It's an H region near one end of a giant molecular cloud. What's an H region?
Fluorescing hydrogen.
Oh,
H2, doubly
H2.
ionized hydrogen.
Right.
H2.
so it's mostly hydrogen there. The old basic. Okay.
Observing this, would it be better to use a UHC filter here or an O3? What would you recommend on that?
I don't think,
Probably either one.
yeah,
Yeah.
no difference.
When I've seen this through the eyepiece, it's really big.
Yeah.
And
Yeah.
I don't know if this, I think maybe the one that looks like a double superimposed donut is that might be the helix, but this one is just really just a big, vast, nebulosity. And in the center, you can see that star cluster.
Mm-hmm.
Well, it's 5,000 light years away, 130 light years across, and 10,000 solar masses.
Yeah, that's the amount of dust. If you made stars out of it efficiently, then you'd get about 10,000 stars.
Wow.
Like our sun.
Yeah,
Therefore,
this is a stage of stellar development. First, you start with the cloud, and you can see out here there's a lot of cloud yet. And then it starts to form these dark areas where matter starts to accrete by running into itself under gravitation. And then it forms stars. And as the stars turn on, they have a solar wind that blows the rest of the dust away. And here's the star cluster that formed in the center, and it's blowing the dust away. So you get several stages of stellar evolution here in one picture.
Wow. Oh, interesting. That's nice.
do you
Mhm.
suppose John Herschel's lady friend was Rosette? Or how do we get that?
I think it's more because it looks like a flower.
Yeah.
Oh, it's a flower, Rosette. It's also a
Rosette.
lady's name, I think.
Yeah. Yep.
Could be wrong. Well, that's fascinating.
Okay.
Other
Now,
part of this.
in this new planetarium software, I do not have control of the horizon yet. I have to find out how to do that. So I took a picture, or had it find Mercury, which is right here at the fingertip, right there. Mercury, it's not a high contrast word. It's also got the sun in here.
Yeah.
So at about very early evening, the it's going down, so the horizon would be going up like this.
Yeah.
And because then near this is a summer constellation, and it's this time of year it's going to set very early.
Yeah,
and Mercury's going to set early too. What's that?
I said this has been tough. I've been looking for it.
Yeah.
The ecliptic is canted very shallowly, from the horizon. So it's even tougher, to see.
Oh, so it's bright.
Mercury's bright. Yeah, but the sun is over there, kind of moving through Scorpius. You can see a little piece of Scorpius there. Okay. In fact, there's Antares. I can see Antares glowing there, just below.
Yeah, right here.
Yeah. Yeah. It's been moving through Scorpius for the last weeks,
And Mars is right there, so it's even harder to
That's
spot
tough.
the sun.
And actually, it's in Ophiuchus. If you look, the boundary goes right between. Yeah.
Yep, right over the line.
That's your sign, Chuck.
Yep.
Mars would be on the far side of the sun. Mercury's always in Earth, so it's never more than how many degrees away from the sun?
Oh,
I think 19 is the limit, something like that.
Okay.
Wow.
And I think it might be the third that it was kind of the furthest from the sun. Does that sound right, Chuck? Around the third? Yeah. It's been really tough. It's been hazy too, which doesn't help.
Yeah, and that was your best chance.
In the early evening, Mercury's about 7 degrees among a flat sea level ocean horizon. And if you make a fist, people can't see me. If you make a fist and hold it out at arm's length, that is about 8 degrees. So it's slightly less than the fist height off the horizon.
Yeah, it's tough.
Confirming that it is hard to spot, even though it's bright, minus 0.4 magnitude.
Well, it's below the star Altair, and it's in constellation Sagittarius, where our black hole and Milky Way center is, isn't it?
Yes, Milky Way is right up in this area, or the center.
Yeah, center's
off it's above the teapot.
Off the teapot.
Right off the spout.
Off the spout.
Mm-hmm.
Okay.
All right, thank you. From Archer's teapot, reminds me I need to pour myself a cup here.
Now,
good stuff.
The last quarter moon happened tonight at 9:49 p.m.
Ooh,
this is a picture and the terminator is going to go right straight down the moon. And you're going to get a lot of contrast at these things right in the middle, things that are hard to see with the full moon. One of them is this, and this is actually taken at the first quarter, because you see at our phrase at last quarter, this is bright. Here it's dark in a shadow. So the light and dark flip for tonight from this picture. This was taken by an amateur who does excellent moon photography in France.
And this is Rupa's rectal exam, or whatever it's.
Yeah, also known as the straight wall.
Right.
And the sword.
When I was a kid. Go ahead.
It's also known as the sword on the moon.
Right, the sword and the scabbard.
Where's the scabbard?
On the top.
On the
well,
top.
that's the handle, the hilt and the handle. Yeah.
Yeah.
Okay. So when I was a kid, we were told it's a cliff. It's not a cliff. It's a straight slope about 50 degrees.
An escarpment.
You would roll down it, but not fall down.
Yep.
Yeah.
Not a fault line. They don't have fault.
To the right of it's named Burt, B-I-R-T.
It is a fault run. It is a fault, but
it's a fault line.
Yeah.
It is. Yep. So there's tectonics on the moon, just like.
Well, no, sort of. I mean, the moon is cooling and contracting, and the crust cracks. So that's what you're getting here.
The little crater that Jerry has his cursor on is on the opposite side from Mark Zako, and that's Bert there. That's a nice feature you can see.
Yeah, this is Artsakel.
Yeah.
So some of these things are pretty big. They're hundreds of miles across. And when one of those slams in, it creates a local earthquake. And so you do get a lot of motion of faults and breakups of things.
Yeah.
And there are longer, slower things like Chuck said, that it's cooling and contracting and causing strain on the surface.
And right below Bert there, near where you had your cursor, if you go down, you can see a rill, which is where there was
Yes.
probably lava flowing under the surface.
Right.
So come up a little, up and left.
That's
There's a
it.
little rill there.
That's
Yeah.
Yeah.
Interesting. I didn't know that.
Yeah,
What's
and
a ri-
and the crater next to Bert is called Bert A.
Bert A.
I didn't know that.
You know, that I would call that Bert B, but I'm sure you're right.
You're
The
supposed
way
to,
I think of things is
I've
never
been
the way
telling
these
people
label them.
at outreaches that this thing was about 100 feet tall. I was wrong. It's about between 800 to 1,000.
Yeah, it's around,
tall.
around
Yeah.
1,000 feet.
Yeah.
That's a big feature.
Slump
Yeah.
fault. Slump fault.
you suppose NASA has any plans to land near it?
Probably not.
Yeah.
What would you see if you got out? A big wall or a
Yeah.
cliff?
Yeah.
You would see a cliff how high?
About
Well, it's not a cliff. It's about a 50-degree slope.
yeah,
Yes.
it's an escarpment, and it would be
Yeah,
a
escarpment.
gentle rise that would be up to 1,000 feet tall.
Okay. So it's about the center of the moon that we see. In this case, the dividing line is right next to it.
Mhm.
We're looking at what is it? Third,
Terminator.
fourth, but
Yeah.
this is the
This is
last
the
fourth.
Terminator, and this is, I believe, the North Pole of the moon.
Oh,
Oh, really?
So we're gonna go down, skirt down
Okay.
we're gonna go down the pole or this region here to look at the features that are available. This
Okay.
region up here is the first picture, and each slice you'll see as we go down.
huh. That's where all the water is.
No,
No,
it's the South Pole.
No,
yeah,
South
it's the
Pole.
other pole.
Really?
But there's probably some at the North Pole too.
Mhm.
Well, the same reasons would apply to both poles, I would think. Sun can't
Yep.
get down in those craters.
Yep.
Okay, gotcha.
The South Pole it can't, but in the North Pole it can eventually get into every part of it. So there's no suspected ice flows in the North Pole that I heard about.
Artemis 3 wants to
Change
go to
all the time.
Okay, Artemis 3 is landing on the South Pole. China is landing on the far side of the moon, aren't they? Pretty much.
They've
Yeah.
already landed there. They're shooting just like we are for a colony on the South Pole.
Do you know what the next Artemis is? It Artemis 2, which is going to be manned, but they don't land, or is it going to be unmanned but go around the moon?
No, they
Well,
already
I
did
don't-
that. So it's going to be manned.
So the next one will be manned and land?
No.
No,
Oh, it'll be manned but won't land. Okay,
Yeah.
so there will be an Artemis 4 that lands? Have you been keeping track?
Well,
Artemis
I
1
think all of that is far in the future because they're relying on Musk.
Jerry, can I ask a question before we leave Rupus Recta? I didn't realize you could see that at third quarter. Would I look for that during the day, the early morning?
Yeah. We lost Jerry for some reason.
Oh, okay.
but can you hear me?
We can
Yeah,
hear
I
you,
can.
but we
We can
can't
hear you,
see
Jerry.
your
Yeah.
image.
Yeah, I bumped a cable here and I heard it go off.
Just as well, Mr. President. The logo looks better than you anyway. Thank you.
Thanks.
Oh, wow.
Yeah, when the moon is waxing, okay, which is not the phase he's showing, Rupus Recta is around a 7-day moon, just roughly.
8 day.
8-day? Okay.
Yeah.
Huh.
So here we're moving down. This is a individual mountain peak that stands on its own.
Oh, I've
Wow.
Anyone remember the name of it?
Pico, I think.
Yeah, Pico is
Okay.
right.
I've never looked for that.
Yeah.
Fire
And
in
with this
the-
shadow, you can actually measure from the sun angle, you can actually measure from the
How
length of
tall it
this,
is.
you can actually measure how high the peak is.
Mm-hmm.
Wow, they're definitely going to want to land near that.
I don't know.
It's got its own Monument Valley.
Yeah. Now we're getting down to the lunar Apennines
Mm-hmm.
and very easy to see this time. This has the very famous crater Copernicus in it. It's very sunlit, so there's not a lot of shadow in it. But this shows the ray system off very nice.
Yeah.
Jerry, who shot these?
This is posted, I think, on a NASA or a Wikipedia site.
Wow, that's amazing.
Yeah.
Might be reconnaissance orbiter.
Okay.
Could be.
Okay.
This is, and there's a couple of rills here,
Mm-hmm.
fractures in the surface.
All right, you're gonna need to tell me what a rill is. I know what a mare is and a crater is. What exactly is a rill?
A gully.
Yeah, gully depression.
Yeah.
That was created by flowing lava?
Yep.
Various things, and a tube that collapsed, something, a crack that opened up. Think of them as an arroyo or a wadi.
I seem to recall one of the Apollo astronauts saying the word rill a couple of times. They must have landed near one.
Hadley Rill, yeah.
Okay.
And here's what is this, Ptolemy?
Ptolemy's, Alphonsus and
Arzakel.
That's it, Alphonsus and Arzakel. And this one's got a nice sharp central peak.
Yeah.
And from pictures like this from Earth, that's where Hollywood got the idea that pretty much all the mountains on the moon are going to be real sharp pointed spires. And so you see in the background of science fiction movies from the 50s, it all looks like, real sharp spires. And now when they landed Apollo 11, we can see that it's all rounded dust covered hills.
So there are no spires except for that one we just saw, right?
There are a few here, yes. There's a lot of little central peaks here. Wow. And now getting on south, here's Rupus Rectus, and you see it's bright here in this picture because this picture was taken at the last quarter moon, not the first quarter.
Okay.
Like the picture shown earlier.
Huh. And you can see the scabbard.
We get down to one of my favorite craters.
All right, Clavius.
Yeah, Clavius here.
Yeah. 2001 Space Odyssey crater.
Yep, that's where they found it.
Yeah, it's probably there waiting for us.
And then the south pole of the moon. Unfortunately, we can't see into the craters to see the ice in there, but someday you'll see little antennas and domes and buildings and stuff. You'll flying along.
Suppose they'll want to take ice skates with them.
I don't know that it's going to be real nice, Zamboni machine type ice, but it might be very dirty, very muddy.
Oh, you never know in modern space technology. Wow. Okay.
Andy Weir, who did The Martian, he also wrote a book called Artemis about a colony, the first colony on the moon, and I'm sure it's down there.
Yeah.
A recent book title?
Actually, it's near the Apollo 11 landing site.
Oh.
Because they have a scene in it where they go out to that, and it's like it has become like a national monument or a lunar monument.
Yep, I remember that now. Yeah, you're right.
Well, did he write the book named after NASA, or did NASA name the program after his book? I'm curious.
Well,
Artemis?
Neither one. Artemis is a goddess of the moon.
And it's a follow-up in history or mythology. It's a follow-up to Apollo, isn't it? Or they're related somehow. Apollo is a god. Okay. Jerry, are you still with us?
Yep, I'm still here.
Don't doze off at your age. It could be fatal.
You look just like a logo.
This is a planetarium software finder chart for Porrima, the tight double star. The reason it's here is because you can, in amateur-sized telescopes, you can split this double into a nice set.
It's a good test for a good mirror.
Virgo, so it's going to be real late at night here or early in the morning, depending on how you look at it.
Oh.
Tom, did you show me that one once?
Yeah, Porrima, that's a tough one to crack, Tim, and it's a good test for how well your mirror is, and also the night. How good the night is.
Okay. Oh, here we go.
Binaries
are us.
So this is a picture. The separation changes. It's a almost magnitude 3 star. It's 2.7. This was a picture. This is what it looks like, or the previous chart about 3 in the morning. And let's see, what is it? Separation on this picture is 6 arc seconds apart. And ideally a 6-inch telescope will split that. It has a less than 1 arc second resolution. But when you look through our Earth's atmosphere, you're really lucky to get resolution greater than or tighter than 3 arc seconds. That's about what atmospheric seeing that ends you up with. Here they're 6 seconds apart. You can tell they're just resolved.
Wow.
The condition you can see also fortuitously down here, you can see a diffraction pattern from another star. And so this is the central part called the airy disk. And then the first ring around it is the first ring. And when in olden days, when they did visual observing only, the definition of visual resolution was when the airy disk of one star landed on the first ring of the next star. That was resolving the 2 stars.
Right.
So this does not show airy disks, which indicates that the seeing was not good enough for this. I don't know why it's here. This may be diffraction around a diffraction around something in the telescope.
Yeah, it's got a weird thing superimposed on it too, because it's not a full pattern.
Yeah.
Right. And if it were a star we were looking at, these stars would show it too, but they don't. So the seeing did not allow it.
And there's a partial square around it, so it looks like maybe there was an sub-image that somebody got rid of and superimposed a circular aperture for the picture.
There's a real faint circular aperture that goes around here. Yeah. And this diffraction image is outside that. So this is like stray light off of something. So it's just a fortuitous show of diffraction pattern.
Well, it's also a superimposition of 2 different images, I think.
Oh, yeah. He's taking a picture of what the scope shows and other things that are not in the sky.
You kind of lost me, gentlemen. Is the bottom right another version of the middle 2 stars?
No.
Well, it looks like it might have been, because there's partial rectangular aperture around it that's been partially wiped out. So maybe he had a blow up here, but then superimpose this picture that's more zoomed out.
Yeah, like a blow up or something.
Yeah.
But this is the picture that was online. So
yeah.
But anyway, according to your notes, this was used by astronomers, I'm not sure when, to prove Newton's theory of gravity, watching the orbits.
These are binary stars that rotate around each other, and their period was your period can be observed, and it allowed them to calculate the gravitational effect between the 2 stars that cause that rotation. So it validated Newton's theory of gravity for this system.
And the reason this one was so useful was the period is short enough that you can measure it in a human lifetime.
But even though most of the stars we see up in the sky are binaries, this is one of the few that we can really see, even though they're a few arc seconds, but you can see them apart, right?
Yeah.
And that's rare.
And this was Newton's theory, not Einstein's, but Newton's.
Newton, yeah.
Okay.
Yeah.
Okay.
Wow.
The first binary discovered was Mizar in the Big Dipper, but the rotational period was such that they couldn't measure it very easily. I mean, this one was much better.
Yeah.
Is that an important star at 7 o'clock in the bottom of the photo? Just curious.
No, that's just
just another star. Okay, nearby.
That's an illustration typo.
But this is Porrima.
So Porrima can be up to 6 seconds apart. In this picture, here they are 2.3 arc seconds apart, and they can be as small as 0.4 seconds apart.
Well, in reality, how far apart are they?
Oh, in actual distance, I don't know.
I mean,
you could figure that out once you have some of the gravitational calculations.
If we were in that system, would the other star be out in the Oort cloud or in as close as one of the gas giants?
Probably somewhere in between.
Okay, the Kuiper Belt.
Yeah, maybe.
Okay.
How
because-
far away is this star? Did anyone get that? How far away it is?
No.
You didn't put it in the notes.
No.
Okay, their orbit is 169 years, so that's going to be out there, outer
Yeah.
solar system.
Are we seeing their orbits edge on? Do they eclipse each other?
No,
No.
What in our solar system has an orbital period of 169 years? That's beyond Pluto, right?
Yes.
no,
Yeah.
no, that's
Oh, no,
that's
no,
more
it's
like
not.
Uranus, Neptune area, more like Neptune.
Okay.
Yeah. Yeah.
Okay.
Pluto's like 248, isn't it, Chuck?
Yeah.
Okay, so they're pretty darn close, cosmically speaking, I guess, aren't they? I mean, you're not going to have binaries that are as far apart as we are with Alpha Centauri.
No, they exist.
38 light years?
38, no, Alpha Centauri is 3.8 life
Yeah.
years.
No, I
No,
mean
no.
the Purim.
Parima?
Yeah, I
Yeah,
think
for its
Parima's-
That's
distance
probably
from
about
us.
right, Tim.
Yeah, it's about 38.1 light years
Mhm.
that I got here. Off
It-
Oh, that's the
Wikipedia.
distance. That's the distance to it.
Yeah, that sounds reasonable.
Oh, I got it, right.
Okay.
But it's also called Gamma Virginis.
Virginis,
Yeah.
yeah.
Okay.
Now the comet student,
You want a pronunciation? I say Sushinshan 1.
I think that we'll go with that. Yes.
All right, that sounds Chinese to me.
It is
Sounds great.
Chinese. It means Purple Mountain, and that's one of their observatories.
And
Yeah.
They found it first, right?
Yeah.
Got to name it.
Yeah.
Sushinshan. And where
This
is
cursor marks the spot. The red bullseye marks where it is tonight. This week it doesn't move very fast. It is traveling through the length of Leo this month,
Mhm.
and this is where it is right now. This is a constellation that will be overhead more in the springtime. Right now, it's early morning constellation.
Mhm. Mhm.
Huh.
No, is that a
It-
double? Right next to it, is that a double star or is Regulus the double?
Regulus
It's
is
the
a
double.
is a double, but Algeba is the one that everybody
Yeah.
tries to split.
Okay.
Gamma Leonis.
Gamma Leonis.
Algebra is here.
Okay.
Another good test double for a telescope.
Well, now it probably goes without saying that any comet is either coming in or going out, right?
Yeah.
Which way is this one going?
This one is coming in. Right
coming
now,
in.
it's recently observed at magnitude 9.6, and it's expected to get about to magnitude 7, but not above it.
Okay. And
So
it's-
will not be a naked eye comet.
you have written just 50 degrees, no, not degrees, arc minutes northeast of Eta Leonis, magnitude 3.5.
Mhm.
All right. So now we got 4 or 5 comets that we've been dealing with, right?
There are hundreds of comets up
So,
of
Ron-
various
Ron,
magnitudes.
Ron, would
At
you
all
like a little
times.
funny? Would you like a little funny since we're
What?
talking about Chinese stuff? You know,
Sure.
Biden recently met with the president of China, right? And it turns out they decided not to take any notes because it would just be a case of he said, she said.
She said, yeah. I remember that. Who was that? Colbert? I think Colbert said that. Yeah.
Colbert said it, yeah.
Yeah. What in the heck is this? Are these mushrooms or telescopes we're looking at?
Looked like
This
sheep.
is the largest. This is the largest telescope on Earth.
My God,
It's
what an
the,
array. Somebody really on
yes.
drugs set that up.
It's they're not randomly placed. They have different lines for different resolutions around them. Draw two line or a straight line between any two of those antennas, and that's how big the telescope would have to have the resolution that those two have when you combine their information.
Hmm.
Is this an artist drawing or is this actually a picture?
No, this is an aerial photograph.
Hmm.
This is
So
the
there-
ALMA array, which stands for Atacama Large Millimeter Submillimeter Array.
Mhm.
Okay. And this was used to check that planet forming disk, or are we just checking
Yes,
something?
this was used to look at the disk. This is the this is a picture taken by ALMA No, it's only partially there. Okay. Taken by ALMA of HL Tauri. Now, this is not the disk that's in the Magellanic Cloud that's in the other galaxy. This is what a disk looks like that's close up in our galaxy. And this is taken by ALMA. So this is the type of work they do with imaging. Now, it's not a snapshot image. They have to take a lot of scans over this thing and then put the image together from the data.
Planet-forming disk underway.
And you can see the gaps there in the debris, and that's probably where you have chunks.
Right.
Well, the rings will become planets eventually, won't they?
They may, or they may not. I mean, they may be between planets.
Are there stars that have rings like Saturn? Or would you consider
that's what you're looking at, yeah.
Well, do we consider the asteroid belt a ring?
Yeah.
It is, even though it's 1 million miles average between rocks. Unlike the rings of Saturn, they're all bunched together, but it's 30 feet thick, and the rest of it is 100,000 miles across.
200,000.
Well, you could split the rings of Saturn inside us and the moon. I've heard.
Yeah.
Wow.
And in March of 2025, the rings are going to disappear for a couple of hours. They're so thin as we pass through the ring plane.
Did we lose you, Jerry?
No, he's there. Or at least his display is there.
Yeah. I think we lost his mic. I think
we lost Jerry. Okay.
He's coming back. I think he's coming back with a vengeance. We got a quarter hour left.
Tim is now the host.
Uh-oh.
Uh-oh.
That's trouble.
But I've got the talking notes here.
Okay.
Oh, good.
I guess there's no picture then. Did you get a picture from radio waves?
Yes, that's what he just showed.
Yeah.
No, the one he just showed was taken in our galaxy.
Yes.
Oh, and it was used by the same large array down in Chile.
Yes.
Chile
they made that same picture.
Yeah.
But in this one, they also used a really large camera that they have on the very large telescope.
Right.
And they got a spectrum. And so that's how they can tell it's a disk, because they can see part of it is rotating towards you and part of it's rotating away. Oh, there he is.
There he is.
Can we hear you?
Yeah.
All right.
Okay.
You could arbitrate this. We don't have a picture of a large Magellanic Cloud disk.
Yeah, there is.
Well, we don't have it, though. The one he just showed it was in our galaxy.
Yes.
Large Magellanic Cloud circles around us. It's one of our satellite galaxies, isn't it?
Yes. And there's an image that's coming up that shows it.
Yeah.
Okay. Is this 4 of those array that we
No,
looked at?
this is a different array called the VLT.
Oh.
And this one was using in the VLT. These things are all ganged together, or they're used individually. One of them was used individually with an instrument called the Muse, which is a spectral instrument. This is the bottom end of the telescope. The telescope is having the instruments bolted on. It's pointing this way, and all these boxes and cooling tubes and cryogenic stuff are to cool the electronics. And it's called the Muse. And took a look at this thing for the first time. And this is a drawing of
what it looks like
from in the Magellanic Cloud.
Wow, look at those
these things before. So anyway, this is a picture taken by first it took them by the Muse, and then they handed it off to the large array of the Muse instrument on the VLT spotted a jet from a forming star, and then
with ALMA they did the disk.
Yeah, they did the disk. Now in here, this is where they were looking, and this is an image. These are progressive blow-ups of the images, and this blue and this red here are Doppler shifted. Remember, this is radio waves, so at least the ALMA is. This one is infrared and visible for Muse. And you can see the Doppler shifted here. This part of the jet is coming toward us. This part of the jet is going away. And so they zoomed in on that. And you can see something in here is rotating.
Can science describe why there's jets? Why would a star in the middle of a system like that decide to burp out both sides?
Yeah, it's the same
magnetic
thing.
fields.
Is that
It's
what
the
it is?
same. Yeah, it's a combination of things, but it's basically angular momentum gone crazy. You have an auditorium full of people, and there's only one door, and someone yells fire, and they all race to the door to try and jam and get out. And so the people squirt out the door at a high speed, like the Venturi effect. But it's angular momentum, and as the thing squeezes down, as it shrinks, it speeds up to going very fast. And all this angular momentum has to go somewhere. And so it gets forced out the poles.
Okay, but we're always talking about these nebulae that are star-forming regions. So what we're looking at here has got to be happening everywhere. How come we don't have a lot of pictures of developing swirling disks of
We do in our galaxy.
Yeah, this is proof of what you just said. It's happening everywhere. And that's the conclusion from this. There's nothing unique about us. There's nothing unique about our galaxy. We're seeing the same things happening in neighboring galaxies that happen in ours.
But I've seen these jets coming out of what they call neutron stars, which are long after a star's imploded, right?
Yeah.
And for a different reason. And even black holes will do that, won't they?
Yeah,
Yep.
but it's all similar reasons. It's all stuff
Yep.
that's rotating rapidly.
Yep.
And sometimes it's really strong magnetic fields adding to that, collimating the beam.
Everywhere around us in our galaxy and in all the other galaxies, there's old stellar systems like ours. We're getting old. We're probably in the middle of the age, and there's newly created ones, and there's dead ones that have become black holes and white dwarfs, and all the stages are around us all the time. But I don't see this very often. This is the first time I've seen a developing disk planets, but it's going to take a while to get them, isn't it? Many years.
Our disk has gone to a later stage. It has formed planets where it can. The asteroid belt is part of that disk that can't form a planet because Jupiter's tidal forces keep tearing it apart. Saturn is another place where there's a disk, but it can't form a bigger body, at least not readily. It's considered to be fairly young and will go away sometime, but mostly because it absorbs the ring or it throws it off in space. It's not going to form another moon. But the remaining disk of the solar system is the Kuiper belt. And then beyond that is the Oort cloud, which is a spherical cavity or spherical structure around us that hasn't formed a disk yet, but it will eventually.
But it was there at the very beginning. It just didn't get involved with the plane of the circular.
Everything starts as a globe. And then as collisions occur or near collisions occur, so they interact, they then average out their motion. And because there's a net rotation of everything, then they can't collapse in the perpendicular to the, or in the direction of the rotational axis. They can't collapse, or they can collapse to form the disk. They can't collapse equatorially because the angular momentum keeps throwing them out. So eventually these spherical globs become disks, and then the disks aggregate into planets or lesser bodies. And that's why there's an ecliptic plane, because they started from a disk.
Wow. And stellar systems like ours don't turn over as we go around the Milky Way, do we? It stays pretty much the same.
It's like a gyroscope. It's going to try to stay the same.
The gyroscopic principle.
Jerry, in cosmology, does the universe have a rotation, or is it?
That's a question. We haven't found it yet, but that's an unanswered question. Does the universe rotate?
I'll bet you it does. Everything has a rotation. Moons around planets, planets around stars. And look at the way they shape up the Milky Way. The galaxies are rotating. Everything
not obvious to me either way. So I'm holding back my judgment.
Fantastic. First planet. And this is the first planet forming disk found outside the Milky Way. So they can't see them in Andromeda and other places.
Not planet
forming. Them there yet.
Yeah.
And
Now
yet
they think they found an exoplanet, which is an already formed planet in the Whirlpool galaxy.
they found a planet in a galaxy?
Yeah,
An exoplanet, yeah.
exoplanet. Yeah.
Extro.
Yeah, when they're in our galaxy, they're an exoplanet, but when they're in another galaxy, they're an exoplanet.
Good
Is that like
Lord.
interstate commerce and intrastate commerce?
Yeah, yeah.
Is it going around a star or is it a rogue?
Yeah, it's going around an X-ray binary system. So that's how they were able to discover it. It was blinking the X-ray stream on and off.
Huh. Interesting. M51?
Yeah.
Oh, wow.
Well, somehow 100 years ago, old man Hubble, sitting at Mount Wilson, managed to pick out one star. He wrote VAR on the negative, remember?
Yeah.
In Andromeda, that gave us the expanding universe, I guess.
No, it gave us other galaxies.
Yeah. It gave us a distance to that galaxy.
Is that what it was? That was before he came up with the expansion, the Hubble constant. Got it. Fascinating.
He didn't come up with the Hubble constant, or did he? It was named after him.
Yeah.
Right.
Yeah.
Hubble
He discovered
parameter
the
these days
effect, yeah.
because it doesn't seem to be constant.
Yeah.
But now they've tied in dark energy to it, haven't they? That's what that concept is. Dark energy is making it go away, right? That's new. I'm thinking.
Your dark matter and dark energy are just other words for we don't know.
Yeah.
Well, recently you gave us some new information. They got some stuff down. There's two types of dark energy, and they're connected to black holes, which makes sense.
No, that was dark. That was dark matter, I think. Who was talking about dark matter black holes. That's
it was dark energy. But they noticed a correlation. They're not claiming an effect or causality. They said that the black holes were getting bigger faster than they could reasonably be expected to accrete matter from their local environment.
And you also had the article about the potential black holes of dark matter early in the pre Big Bang.
Oh yeah, the second Big Bang, the first Big Bang then of two. Yeah. Now those are all speculative hypotheses. And this stage of physics, when you really don't know a big thing, speculation is all over the place.
Well, it makes sense to me. Dark energy seems to be what's propelling everything out, and dark matter just does the opposite. It keeps the galaxies from flowing apart.
Yeah, those are the things that we do know, but we don't know what the makeup is of those things.
Right. Could be that the universe is not expanding. We're just all shrinking.
Oh, don't start me on that, my God. Although it'd be a hell of a diet. I could do that. Bless your heart. Well, we're down to the wire. Is there anything else on the plate, Mr. President, newly reelected? We are going to be on target in 2 or 3 weeks on Monday morning, December 25th, which happens to be Christmas Day. We will be here, most of us. We got no other lives. We got grandkids coming and going, and by 11 they'll be out playing and breaking your toys, playing with what you gave them.
I'll try.
Actually, no, we'll be out buying batteries, right?
Yeah.
Right.
I'll
putting
try
it together.
to get here, Ron. So I'll be here too.
Well, congratulations, Mr. President, and congratulations to your wife, Pat, Chuck, for now taking on. Actually, we love it that she's willing to. Has she been treasurer before?
Yes, years ago.
And is Colin checking out to go check into the Mayo Clinic or something? Our former treasurer.
No, I mean he's been treasurer for a long time. I mean he was doing secretary for a while, so I think he's getting a little crispy. He's tired of it. So
yeah.
And Tessa Flanagan is willing to be secretary, but she's got health problems.
We'll see on that, Ron. Maybe
okay. Well, we'll have a big meeting online this coming Saturday afternoon, followed by the Star Party. And we're just going to have more fun and learn in this continuing incredible UCSB astronomy course. Thank you, Tom and Tim and Jerry and Chuck, and we'll see you in a week, and we'll do number 147.
Yep.
Thank you, and keep looking at the
Bye.
stars.